Hi, let's continue from where we left. Okay, so this is the next topic. If we have to find the range of this expression, that is a sin x plus b cos x, that is given to us, and we have to find कि इस फंक्शन की वैल्यूज कहाँ से कहाँ तक जाएंगी. So ऐसा करते हैं, यहाँ पर एक टर्म गिवन है a और एक टर्म गिवन है b. दे आर द कोएफिशिएंट्स ऑफ sin x and cos x. तो अब अगर मुझे रेंज निकालनी है, I'm going to multiply this expression and divide this expression by under root a square plus b square. So let's see what is going to happen. This is equal to under root a square plus b square divided by under root a square plus b square. If I multiply this thing with the entire expression, which is a sin x plus b cos x, up I can take this denominator inside. So I'm going to write this as, and this as, okay. So now let's try to visualize. This is sin x multiplied with a upon under root term. This is cos x multiplied with b upon under root term. Let's try to visualize a, b and this under root term by using a triangle. If this is my angle alpha, then I am having a upon under root of a square plus b square. Let's say this is a and this is b. Then by Pythagoras theorem we can say that hypotenuse square is equal to perpendicular square divided by, hypotenuse square is equal to perpendicular square plus base square. So I can calculate the length of hypotenuse as a square plus b square. Now let's observe over here, a upon under root a square plus b square, that is base upon hypotenuse, that is cos alpha. So I'm going to substitute this term with cos alpha. Then let's observe b upon under root term, that is perpendicular upon hypotenuse, that will be sin alpha. So this will be replaced with sin of alpha. So let's see what have we created. We have an expression over here, a square plus b square multiplied with sin x cos alpha plus cos x multiplied with sin alpha. So now in our previous lectures we have derived a result which says sin x cos alpha plus cos x sin alpha can be written as sin of x plus alpha. This can be written as sin of x plus alpha. And since we all know that the value of sine ranges from -1 to 1, this was covered in the previous lectures, that the value of sine increases from -1 goes till 1, and since it's cyclical, that will again reduce from 1 to -1. So the value of sine, this expression is going to vary from the value of sine of x plus alpha belongs from -1 to 1. And if I'm multiplying this thing with this, the result is under root of a square plus b square multiplied with sine of x plus alpha. So the result will be multiplied with it, and I'm going to write minus of under root a square plus b square comma under root a square plus b square. So this is the expression that is for the original one. A square plus b square under root with a minus sign से लेकर root of a square plus b square. This is the range of the original expression. Now let's try to solve some questions based on this phenomena. If I have this expression 3 sin x minus 4 cos x, let's substitute it. This is a sin x plus b cos x. What will be the value of under root of a square plus b square? It will be under root of 3 square plus minus 4 ka whole square. So it can be written as 3 squared, that is 9, minus 4 ka square is going to be 16. So this will be under root 25. I'm going to substitute it with 5. And since we remember that the value of this expression ranges from minus of under root of a square plus b square to under root of a square plus b square. So I can say that the original expressions f of x, the value is going from minus of this term to positive of that term, and that term is 5. So the answer will go from -5 to 5 closed intervals. Why am I having closed intervals? Because the value of sine ranges from -1 to 1, and both -1 and 1 are included in the range of the function sine. Now let's solve next question based on the same type. Now this is using two phenomena. One, the previous one which we studied, and the second phenomena is the formula of sine of a plus b. Let's quickly expand this. Twice of sine x plus 30 will be sin x cos 30 plus cos x sin 30 minus 4 cos x. Let's see what just happened. 2 was copied as it is, then sin x plus 30 was expanded into two terms, that is sin x cos 30 plus cos x sin 30, and we also have to subtract minus 4 cos x. So now what is the value of cos 30? Please put it down in the comments. Okay, cos 30 is root 3 by 2. And what is the value of sin 30? It is half. I can say this is twice of root 3 upon 2 multiplied with sin x plus half of cos x minus 4 cos x. So now if I multiply 2, what will this become? Root 3 sin x plus cos x minus 4 cos x. So now this is plus cos x minus 4 cos x, so it can be written as root 3 sin x minus 3 cos x. I have to find the range of the expression, so I'm going to calculate the range by using the formula which we just derived. The formula was under root of a square plus b square going from negative to the positive of this term. So in order to substitute the values, let's see what is a. A over here is root 3 and b is minus 3. So under root of a square plus b square will be written as root 3 ka square is 3 and minus 3 ka square is 9. So it is going to be root 12. Root 12 can be written as 2 root 3. So this will be written as minus of 2 root 3 se lekar 2 root 3. So the range of the expression is going from minus 2 root 3 to 2 root 3. Closed intervals, because as we discussed, sign includes the value minus 1 and 1. So this expression is going to include the extreme points. Okay. Let's solve another question based on the same phenomena. It doesn't matter if sine comes first or cos comes first, the logic will remain the same. So since over here sine precedes and cos is the first term, the formula will remain the same. Let's calculate under root of root 3 square plus minus 1 ka square, that is a square plus b square. This is going to be under root of 3 plus 1, that is root 4, which can be written as 2. As we remember, the value of the function f of x belong from minus under root a square plus b square to under root of a square plus b square. So this is going to be 2. So it is minus 2 to 2, closed intervals, because the extreme points are included in the expression, as sign can be minus 1 and 1. Okay, if there is any doubt, please feel free to ask in the comments. Okay, no issue. Let's move forward. Now, let's have a look at this expression. If I have sin x plus cos x and I have to express this term as one single term, over here it is a sum of two trigonometric ratios. If I have to simplify it in the form of just one trigonometric ratio, so I am going to multiply and divide by root 2. Why am I multiplying and dividing by root 2? Let's calculate under root of a square plus b square. As we discussed in the previous slides, a is 1, b is 1. So it will be 1 plus 1, that will be root 2. Since the value is root 2, I am going to multiply and divide this expression by root 2. So it is root 2 upon root 2 multiplied with sin x plus cos x. Taking the denominator inside the brackets, I will get root 2 1 upon root 2 sin x plus 1 upon root 2 cos x. Now in this expression, we all remember the values from class 10th, that 1 upon root 2 is the value of sin 45 and that is the value of cos 45. So now I can substitute the values over here and I am going to get root 2 over here. I am going to substitute the values. I am going to get root 2. Now this is sin x into 1 upon root 2, that is the value of cos 45, plus cos x 1 by root 2 is the value of sin 45. So now we remember the formula, sin x cos 45 plus cos x sin 45 can be written as sin of x plus 45. So it is root 2 sin of x plus 45. So if we see the expression sin x plus cos x, it can be substituted with root 2 sin of x plus 45. There is another manipulation that's possible over here. Let's have a look at that. If 1 upon root 2, instead of being cos 45, I substituted it as sin 45, then this thing would have become under root 2, 1 upon root 2, I am substituting it as sin 45. So I am going to put sin 45 sin x plus cos x. I am substituting 1 by root 2 as cos 45. So यहाँ पर I will put cos 45. So now let's observe. This is cos x cos 45 plus sin x sin 45. That's the formula for cos x minus 45. So I'm going to write it as root 2 cos of x minus 45. And as we know, cos of theta is the same thing as cos of minus theta. As we discussed in the previous lectures, cos consumes the negative. So this thing can also be written as root 2 cos of 45 minus x. They both are the same thing. So now sin x plus cos x can either be written as root 2 sin of x plus 45 or root 2 cos of x minus 45 or root 2 cos of 45 minus x. I hope that was clear. If there is any doubt, feel free to post in the comments. Okay, let's proceed to the next slide. Okay, now if we have to calculate the value of sin x minus cos x, let's repeat the process which we discussed just now. The coefficient of sin is 1, the coefficient of cos is minus 1. So the formula is under root a square plus b square. That is going to be root of square of 1 plus square of minus 1. So this will be under root 1 plus 1. That will again be under root 2. Multiplying and dividing the expression by root 2, I am going to get root 2 upon root 2 multiplied with sin of x minus cos of x. Let's take the denominator inside the bracket. I am going to get root 2 1 upon root 2 1 upon root 2 sin x minus 1 upon root 2 cos x. Again, applying the same logic which we did in the previous topic. 1 by root 2 will be substituted as cos 45. So I am going to write root 2 sin x cos 45 minus cos x sin 45. Now this is sin x cos 45 minus cos x sin 45. This is the formula for sin x minus 45. So this is equal to root 2 sin of x minus 45. Now if instead of putting 1 by root 2 as cos 45, I had chosen sin of 45, then let's see how the result would have turned. So now over here I am going to substitute a bit in a different manner. Sin x into sin 45, then minus of cos x into cos 45. Okay, so as we remember, the formula contains cos minus sin. So I have to take a negative term outside common. This will become minus and this will become plus. So now the formula is cos x cos 45 minus sin x sin 45, which can be reduced to writing it as cos of x plus 45. So it will be minus of root 2 cos of x plus 45. So if I have the expression sin x minus cos x, it can be written as root 2 sin x minus 45 or minus root 2 cos of x plus 45. Please note it down and post the questions in the comments. Okay. Now let's discuss next set of formulas, which is known as sum and difference of trigonometric ratios of two angles. That is to say, trigonometric ratio of A plus minus the same trigonometric ratio of B. Let's quickly revise what we have studied in the previous lectures. Sine of A plus B can be written as sin A cos B plus cos A sin B. Then if I have the formula of sin of A minus B, it can be written as sin A cos B minus of cos A sin B. Now let's quickly add these two equations. What am I doing? This is equation number 1. This is my second equation. Add first and second equation. If I am going to add the first and second equation, what am I going to get? On LHS, I'll get sine of a plus b plus sine of a minus b. On the RHS, these terms will cancel each other and I am going to get 2 sine a cos b. Now let's quickly see how I can simplify this expression. Okay, let's have a look over here. If I substitute a plus b as c, a plus b is equal to c. Let's say that a plus b is equal to c and a minus b is equal to d. If a plus b is equal to c and a minus b is equal to d, I'll call this as my third equation and this is my fourth equation. Let's do another thing. Add equations 3 and 4. Add equation 3 and 4. On the LHS, I'm going to get twice of a is equal to c plus d. A is equal to c plus d upon 2. And if a is equal to c plus d upon 2, let's use the third equation. I can say b is equal to c minus a. Substituting the value, I'll get c minus of c plus d divided by 2. This becomes 2c minus this term. So it will be c minus d upon 2. So now I have the values of a and b which I am going to substitute in this expression. If I substitute the values, I am going to get a plus b. A plus b is equal to c. So this expression can be written as sine of c plus a minus b over here can be substituted with d. So it will be written as d. On substituting the values of a and b over here and here, I'll get the formula twice of sine c plus d by 2 multiplied with cos of c minus d by 2. A is equal to c plus d by 2, b is equal to c minus d by 2. This is c minus d upon 2. Okay, so now we have come to the conclusion that if I have sine c plus sine d, I can write it as 2 sine c plus d by 2 into cos c minus d by 2. Similarly, we can derive the formulas for other trigonometric ratios as well. I'll quickly write them down. So what is the formula which we have studied? We have studied sin c plus sin d, that is 2 sin c plus d by 2 cos c minus d by 2. If someone asks you sin c minus sin d, this is 2 sin c minus d by 2 cos c plus d by 2. If someone asks the formula for cos c plus cos d, that is 2 cos c plus d by 2 cos c minus d by 2. If someone asks the formula for cos c minus cos d, cos c minus cos d, this is 2 sin c plus d by 2 sin d minus c by 2. Now that's the tricky part. In the last one you have to write d minus c, not c minus d. Please note them down. We'll move forward to the next slide. Okay, let's end it today and we'll move on to the next slide in the next lecture. Thank you.